Okay, in transformer, what happens? There will be a primary winding, there will be a secondary winding. Okay, there will be a voltage V1, then there will be a voltage V2. Okay, voltage regulation is nothing but the change in voltage in secondary terminal from no load to full load, keeping the primary voltage constant, is itself is known as the voltage regulation. Okay, what is the secondary voltage here? V2. Okay, that is V2 naught minus V2. This is no load, then this is on load, divided by, okay, whatever the changes used to be happened. Then with respect to that, we have to express that percentage in terms of full load secondary voltage only. But thing is that you have to remain primary voltage constant. It should not be changed. That itself is called as regulation. Okay, if you multiply this is by 100, then you can get it, that is in terms of percentage. What I'm writing on screen is visible now. Anyone confirm?
Yes, sir.
Thank you. Okay, this is what voltage regulation. Okay, because in your laboratory they might be asking. Okay, that is the reason which is to be present. Okay, you remember this definition which is to be important. Okay, because these are related to the electrical, they might be asking you. Next, with respect to the efficiency of the transformer. Okay, some of them you have conducted the experiment to measure the efficiency of the single phase transformer. Okay, what is efficiency? Okay, here there will be a primary, then there will be a secondary. The power will transfer from primary winding to secondary winding. But this will have the device. Okay, but whatever this device is there, means whatever the static machine is there, will also have some losses. Okay, because of that reason, whatever the amount of power input I given, the same amount of the power will not be available. Okay, so that efficiency of the transformer is itself is defined as the ratio of power output to the power input. Okay, what is the output is available at secondary to that of primary. Primary is what? Input power. Secondary power is what? Output power. The ratio of output power to the input power is itself is called as efficiency, but which is always expressed in terms of percentage. Okay, what is the output power? Okay, this is V2 I2 into cos pi 2. Okay, this is V1 I1 cos pi 1. Okay, you note it down this. Otherwise, you take a snap. Efficiency is equal to output power is what? V2 I2 cos pi 2. Then input power is what? V1 I1 cos pi 1. Okay, because output is available at secondary. Input is available at primary. Okay, modify that. Then efficiency is output is what? Input minus losses. Input minus losses. Then input will be keep as it is input. Okay. Then what are the losses are present in transformer? One is copper loss. Then another one is iron loss. Okay. From this way also we can evaluate. Okay. We know the input power. Okay. Then we know the losses. Then I will get efficiency. Okay. This is also one of the way you can make the evaluation of the efficiency, because in problem they might be giving in any type. Then you have to recall, then you have to reconstruct the or reframe the formula, then you have to evaluate. Okay, whenever I'm solving with respect to the problem, you will understand. Nothing to worry. Is this clear? Efficiency. Okay, that is V1 minus I1 into cos pi 1 minus I1 square into R01 minus Wi divided by V1 into I1 into cos pi 1. Okay, then we are taking that with respect to that of evaluation. Okay, this whatever the denominator is there. Okay, we are splitting that into that 1 minus I1 into R01 divided by V1 into cos pi 1, Wi divided by V1 into I1 into cos pi 1. Okay, this is also one of the method which is to be used to make the evaluation of efficiency. Okay, keep all these things formulas. This also be important for the examination point of view. Then condition for maximum efficiency of the transformer. Okay, when we are going to get the maximum efficiency if you are provided a input power to that of transformer. Okay, that is the what? The condition of maximum efficiency. At what instant we can achieve maximum efficiency? Okay, as we already know, what is the efficiency? Efficiency is the output power to that of input power. Okay, V1 is primary voltage, I1 is primary current, cos pi 1 is power factor of primary, R01 is primary winding resistance. Then efficiency will be defined by what? The ratio of output to the input. Okay, then output will be represented by what? Input minus losses divided by input. Okay, V1 I1 into cos pi 1 minus I1 square into R01 because I square R itself is copper loss. Okay, Wi is what? Iron loss. Okay, divided by V1 into I1 into cos pi 1 because input power in case of AC circuit P is equal to Vi into cos pi. Okay, 1 is for primary, 2 is for secondary. Then we'll get 1 minus I1 into R01 divided by V1 into cos pi 1 because this I1 and 1 I1 will get cancelled. Okay, from this. Then we'll get I1 into R01 divided by V1 into cos pi 1 minus Wi into V1 into I1 into cos pi 1. You might be studied, okay, in your differentiation. When you will get maximum value, whenever you are differentiating a parameter with respect to the variable parameter, which is equal to 0, then I can get maximum value. The same principle will be used. This is our efficiency. Which parameter is variable? Current is the variable parameter. Voltage is constant, power factor is constant, then resistance is also be constant. What is this? Iron loss? Iron loss is also be constant. Only the parameter is variable is I1. Okay, that is the current. As the load changes, current will changes. So that the differentiation of this efficiency with respect to the current I1, 1 minus I1 into R01 divided by V1 into cos pi 1 minus Wi into V1 into I1 into cos pi 1. Okay, if you did differentiation, what happens? Differentiation of I1 is R01 divided by V1 into cos pi 1. But the differentiation of 1 is what? It is 0. Okay, then differentiation of 1 divided by I1 minus 1 divided by I1 square because minus 1 by x square. Okay, you might be known this differentiation. Minus into minus, what will happen? Which will become plus. So that Wi divided by V1 into I1 square into cos pi 1. Okay, then I will take this to right side. Okay, that is R01 V1 into cos pi 1 which is equal to Wi divided by V1 into I1 square into cos pi 1. Okay, this V1 cos pi 1. Okay, then V1 cos pi 1. Both will get cancelled. Then I1 square I will take this side. Then I1 square into R01 is equal to Wi. What is this I1 square into R01? I square R1. Which loss it is? Anybody? Just now I told in losses in which loss?
Copper loss. Copper loss.
The copper loss. Okay. Wi is the iron loss. What the condition of maximum efficiency? Whenever copper loss is equal to iron loss, then we'll get maximum efficiency. This is the what? Condition of maximum efficiency of the transformer. Okay, whenever the iron loss is equal to copper loss, we can get maximum efficiency allowed. Is this clear?
Yes, sir.
Yes, sir.
Raise your hand. Only 12, 21, 22. Okay, thank you. Drop your hands. Okay, that is with respect to the what? Condition of maximum efficiency. It is defined here. Okay, whenever that iron losses or the copper loss is equal to each other, then I will get maximum efficiency. Okay, that is iron and copper losses should be equal. Okay, then what is the copper loss with respect to that one? I1 square into R01, I1 is equal to Wi divided by R02 if you are considering with respect to the secondary. Okay, this is most important. Okay, practice this. Condition for maximum efficiency. Define efficiency, then derive the condition for maximum efficiency they will ask.